good morning, good evening, wherever you're tuning in from. Really looking forward to talking to you about automotive 3D scanning today. We have two great guests. I've got Dom Tucci from Tucci Hot Rods and Carl Burdine from our ambassador Digitize Designs, who set Dom up with Artec Leo, our handheld 3D scanner. So before we dive into kind of how 3D scanning works in this industry behind the scenes, I'll give you a quick run through who Artec 3D are, how our products work, and why they're relevant to the industry. I'll then invite Dom and Kyle on stage, and they will take turns to talk you through how the technology works in practice and hopefully give you kind of a preview of how the scanners work in action and give you some behind the scenes tips as well. So, what will we explore today? So, we've got an introduction to Artec 3D scanning, as I mentioned, how 3D scanning is used in automotive. We'll cover off some use cases in real life. Then I'll get Dom on stage. And then at the end, you'll get the chance to answer some questions. So who are Artec 3D? So Artec 3D, we specialize in developing 3D technology. We develop the hardware and the software side of things. And essentially all our products are designed to create really accurate, highly detailed digital twins. As you can see, we've been around for a little while now, since 2007, and here are some of the awards we've won. And this is our product lineup. So we've got Evo, which is our kind of our longest serving structured light 3D scanner. We've got Leo, which is used in this project. It's like really flexible. It's wireless. It has a built-in battery display. You don't need a laptop carrying around with you. Spider 2, really high resolution. Point, which is our highest accurate handheld. Jet, our newest edition, which is for sort of really long range site scale stuff. Micro 2, which is for micro scale scanning, and Ray 2, which is like a LiDAR tripod mounted scanner. All of these products operate in the same ecosystem in Artec Studio, and we've just introduced Artec Twins for Jet as well. And we'll dive a little bit more into those as we go through, but essentially this is our core product lineup. And here are some of our most famous customers. I'm sure you'll recommend, or you will recognize, I should say, some automotive OEMs here, world famous ones that use our technology for reverse engineering and inspection. So in terms of our product lineup, these are the three most relevant. So we've got Artec Point, as I mentioned before, really highly accurate. It's a metrology grade 3D scanner for capturing small parts and even assemblies. Ray 2 is for capturing stuff from a longer distance. In this case, it's great for combining with Artec Leo to create like a really highly detailed scan from a distance that can be used for simulation and analysis. And Artec Leo, which is the scanner used by Tucci, is completely wireless, as I mentioned, but it's also super fast and highly accurate as well. So you get that speed without compromising on the detail. So Point has three modes. You can see one of them here on the left-hand side. It has sort of parallel lines. It has a single laser line for capturing holes and hidden geometry. And then it has a grid for capturing at really high speeds. I think it has 120 FPS, so it has really great tracking. You can see in the middle there an example of the kind of detail that you can capture on an automotive part. And then on the right-hand side, you can see what looks like the inside of a wheel, and even really difficult to capture things like holes and ridges and grooves are captured in the final model there. Ray 2, as I mentioned, is for like a longer range. So we've got a huge truck here that was scanned by one of our partners, AirShaper, and they used it for airflow analysis. And you can see Ray 2 and Leo being used in conjunction. So you have scale, you've got the accuracy where you need it, and you can combine the scans in Artec Studio. And then lastly, we have Leo, which is the star of today's show. It can be used for interiors, again, automotive parts. And in conjunction with Ray, you can capture entire vehicles. So this vehicle on the right-hand side was a whole fire truck that was captured with our products for a video game for farming simulator. Some of you may have heard of it. So as I mentioned before, all these scanners can be combined together in Artec Studio. This is like an all-in-one software nowadays. So it's not just about capturing a scan and fusing it into a mesh on the processing side of things. It also has other features for reverse engineering and inspection. For example, you can go from scan to CAD with auto servicing. We have things like deviation mapping, so you can compare to a CAD model. We can import the CAD model and compare the mesh with the CAD. And you can even use, it has built-in photogrammetry. So you can use it for things like visualization. So you just do a quick lap around with your smartphone, or if you have a professional camera, you can use photos and videos to do a quick visualization. Just from a marketing point of view, that can be quite helpful. And all of these outputs can be sent elsewhere quite easily. So you can send to SolidWorks and Geomagic Design X, Control X. We have really great integration here. Some of them even have built-in macros. So basically, you're not just tied to our software. You can send the mesh elsewhere for follow-up editing or even in-depth inspection from an industrial standpoint. So what does that process look like? So broadly speaking, we've got scanning. So you would, with Artec Leo, for example, you scan your vehicle, if it's a car or a truck, whatever it might be. Make sure you close the loop, you capture it from all sides, and you have this built-in display that tells you when you've got all the data you need. From a processing point of view, you then send that into Artec Studio. You can tidy up, remove outliers and things like this, and you can combine all your scans into a one watertight mesh, which is perfect for reverse engineering. Or if you want to do inspection, basically what you would do is not remove the outliers or not remove too much from the original scan data. You would analyze that as is because you don't want to introduce any artificial data here. And then from then on, you can either export as CAD for manufacturing, STL, which is the go-to in 3D printing still, and OBJ is similar. Or you can send to places like we've got Innometric, we've got Geomagic and SolidWorks, and as Dom Tucci will explain later on, it also works with Rhino and other commonly used data editing software, shall we say, and inspection softwares as well. So whether you want to redesign, manufacture, or inspect, you can use our scan data to perform all of these tasks. So before I hand over to Dom, here are some other real-life use cases where our scanners have been used for different applications. I've tried to take a fun approach and look at all the different kind of vehicles that we've scanned. So we've got everything from motorsport to supercars, service vehicles, and OEM parts that have been customized on request. So this is actually about simulation rather than manufacturing. We're talking about CFD, computational fluid dynamics. And in this case, we have a company in the UK called Catesby Projects, who scan vehicles, sometimes in really high-level single-seater motorsports, shall we say, without giving any names away. And what they do is they scan the wider vehicle with Ray 2, then they get up close and scan the individual components with Leo. And what would previously take like a week or two scanning these very complicated vehicles piece by piece, now they can do it in a single day or two if they're being really thorough. And then they can use that model to kind of optimize setup. Let's say they go to a racetrack that is really high downforce. They can optimize the high downforce setup using the model that they captured with our scanners. And without this CAD data, as you can see on the right-hand side here, why did they choose us? Without this CAD data, which is very sensitive, it's very well-protected information, if you like, because it's sensitive, you wouldn't be able to do this simulation. So without our products, it simply isn't possible to do the things that they do. Arguably, the same can be said of supercars. So this is another of our customers, this time in the US, Aesthetic. And what they do is they customize cars, often very sporty cars. This is like a classic Subaru kind of Impreza, road-going Subaru Impreza. And what they did was they customized the hood and they customized the front bumpers. And before, they could use like manual measurement, but it really wasn't very effective. It wasn't very fast, and it didn't allow them to keep up with customer demand. Switching to our scanners means that they're now able to customize these much faster. Upgrading to scanning really allowed them to, well, I say upgrading to scanning, upgrading to Leo. So they had Evo before. Upgrading to Leo allowed them to go wireless as well. And yeah, Artec Leo really is a fairly unique proposition in the market still, in the sense that it's wireless. It's this fully compact, all-in-one device. And upgrading from Evo to Leo really allowed them to upgrade their workflow. Service vehicle-wise, we have this rather cool-looking off-road vehicle that was customized. The booth on top of the vehicle was customized using Artec Leo. And again, you can see the lead times in the solution section there. Before, it would take 4 to 8 hours to scan the geometry. Now they can complete this workflow in less than an hour. And that allows them to customize these enclosures much, much faster. We're talking from days down to hours. And the benefits, the business benefits of that, the return on investment are clear. If you can do what used to take 8 hours in 1 hour, you can get through more customers in that time. You can free yourself up for more value adding tasks. And yeah, for them, this is from a few years ago. We first reported on this customer. They still use our products today, and it's great to see them still going strong. And then lastly, before I hand over to Dom, we have this OEM modification. So this is a Ford Bronco that was owned by CPE and other of our US clients. And essentially, they were asked to customize what was at the time a brand new Ford vehicle. So Ford themselves had kind of the standard part on file, but if they wanted to customize this for a customer, they would need to remove the part, scan it on the ground, and customize it to customer specifications. I think in this case, it was about making it sound a bit more raucous and a bit more interesting to listen to. But theoretically, you could do it for any purpose. You could optimize the aerodynamics of the car. You could do it to actually improve the performance of the engine. So in this case, we're talking about slightly cosmetic things, but it certainly isn't limited to that. And as you can see from some of the stuff on screen, the customer in this case was able to scan the underside of the body, remove the tailpipe and scan it on the ground, and then send the data to SolidWorks. And doing so, as you can see with the car on the jacks, would have been very difficult with a cabled scanner or measuring with calipers. It would have taken an awful lot longer and been a massive inconvenience. In this case, they could go from Artec 3D scanning to Studio to SolidWorks. And that workflow works really well for them, not just in this case, but in many other cases as well. So hopefully that gives you an overview of Artec 3D scanning for automotive. This is broadly what it looks like. And now is the moment you've all been waiting for. Time to hear from an actual expert, from Dom Tucci.
Hi, everybody. I'm Dom Tucci with Tucci Hot Rods. I'll give you a little bit background on the shop. My dad started it in 1997. My grandfather actually built hot rods just as a hobby, and then my dad really took a liking to it and started to gain some traction locally, working on people's cars. And he actually started in drag racing, so it was kind of like the performance side of it, and then got into more of the custom stuff and you know, metal fabrication. So that's kind of what we're known for, is the metal fabrication. Um, he was trained under a guy named Fay Butler, to kind of hone the skills that he was working on his own. This is a 35 Ford Coupe that he built for an award called the Riddler Award. So like everything's got to be completely customized, a lot of handmade stuff, a lot of machined parts. The amount of work, this car took 9 years to build. Just really, really intense stuff. But we take vehicles from, somebody will bring us a completely stock car and then we'll modify it from there. We do a lot of motor swaps, suspension swaps, just making stuff run and drive better because people want to enjoy these cars, and the factory stuff sometimes is not quite enough. But we do try to keep a vintage style with, try to keep them era correct. These are a few other vehicles that we built. This is a 35 Roadster on the left, and then a 41 Cadillac on the right. The 41 Cadillac actually has a full Corvette drivetrain in it with the supercharged North Star engine out of the XLRV. So it drives and handles like a Corvette basically, but it looks like it's from the 40s. And then we also have done 7 Ford collaboration projects for the SEMA show. So what we do there is they give us a base vehicle, and then we have, a theme laid out for it and the modifications laid out for it. And we build the car. It's usually a really, really tight timeline to get it to SEMA. It's we usually have three or 4 months from start to finish. So scanning comes in handy a lot with these projects. So we've got to do some pretty neat stuff with them. As for myself, I went to Syracuse University and I graduated in 2015. Really started using 3D printing pretty early on. It was 2016, we were using 3D printing to make end use parts for. We built a Fiesta for Ford, and that was the project that we first used 3D printing on. So we kind of became known for 3D modeling and using 3D printing for actual parts. Um, I actually started 3D scanning with the Xbox Kinect camera, and that, I mean, it got us to make a couple surfaces where I could pull some data off, but it was like not that accurate at all. So when we moved to the Leo, it was like a whole new world. So I have three separate projects laid out that we use scanning pretty heavily for. This is a 41 Willys truck. So this is a fiberglass body. So we did a lot of molds and a lot of things to slightly change the body in ways that we wanted. And we actually built the chassis from scratch for this truck. So we pretty much started with a cab, a hood, and front fenders, and that was it. So one thing with the 41 Willys is that it's got a really peaked hood, and we wanted to try to streamline that a bit. So you can see in the photo on the left how kind of squared off it is. So the photo on the right, we took a wedge cut out of the hood. So we took about 1 inch out of the front and then nothing out of the back to drop the whole front of it down slightly. So from there, we could take a scan. And so I scanned the whole area, and we actually 3D printed a mold that we could then lay up fiberglass on the inside of to completely change the nose shape. So on the left there is the mold bolted to the hood to make sure the fitment was all correct. And then the photos on the right is how the underside of the mold looks and how we laid up the fiberglass to it. And then this is how it ended up. So the whole peak is laid back probably 8 to 10 degrees, and then the whole top of the hood was pancaked. So it just makes for a much more streamlined look on the truck. It's something that we wanted to do from the very beginning, and scanning it, making a mold was definitely the way to make sure one, both sides matched perfectly, and it just sped up the process a ton. This is a fender vent that we designed for a 70 Mustang. We had this car at the SEMA show in 2024, and the Mustang GTD had just come out, and our customer was wanting to do some. It's got a really big fender vent on it, and so our customer was wanting to do something kind of similar to that, sort of like Porsche GT3, GT2 RS style fender vent. So this one was a ton of back and forth scanning and fabricating. So we started with some sketches to get kind of the shape that we wanted to, and we scanned the fender completely factory to start making the shape that we wanted it to be. And this was just a kind of rough cutout of where the vent was going to live. So once that hole was cut, so you can see on the left the scan with the wheel model all in place, trying to see where the clearances were. We could actually take the information from the inside of the fender well to make sure everything was going to clear. And so we started to cut out, a good part of the fender, and we could scan that opening, and we could start 3D printing parts to go into it. And then we had a surface made in CAD that we wanted from the door to lead into the fender vent to make a really nice transition. So I could laser cut out these little profiles. So when we're fabricating the metal, I could keep checking back. So once that was, in place and where we wanted it to be, we could then take another scan of it and make the final shape of the vent, how that was going to be 3D printed, how that was all going to fit. Um, Pretty happy with how pretty much there's no hardware visible, everything's hidden. And I mean, we wouldn't have been able to go back and forth with such a complex shape like that without scanning it. So I was able to use the surfaces to cut um, the model where it needed to be, to install all the hardware, all that stuff. We could we could do from the scans. And this is how it turned out. The middle of the vent actually is functional to from the engine bay. So as you're driving, it pulls heat out of the engine bay. And then the kind of front area and the bottom area, they're open to the wheel well. So aerodynamically, I mean, this is not a race car. This is a street car. It's more visually, but it does serve a purpose where um, high you would have a high pressure zone in the wheel well. So as the more air you can vacate from the wheel well, the more downforce you can have, and the less high pressure you would have in there. So that was how that one turned out. This last one I have here is on that 41 Willys again. So in the little promo video that we made for this, I showed how we did the tunnel. And we also did part of the firewall, scanned it, made a 3D printed mold that's got a spot for the brake booster and everything. So we laid that all up. Now we needed to hang everything, all the accessories, fuse panel, air conditioning, the brain for the gauges, all that stuff had to all tie together. So started by actually fabricating the bar that goes across. I think this right here. So started by fabricating that, getting that tacked in place. Then I could take a scan of those tubes, which it's all hand fabricated. It's not perfect. So scanning it really lets you know where things are off by a little bit. So I could take that scan and then laser cut out the mounts for the AC, and that's for the fuse panel as well. So all those slot right onto the tubes that we made. We could tack those in place. Then we take another scan of those things in place to then move on to the next parts, make sure everything's got clearance. So we have the column mount, and then the area on top is actually part of the dash. So that bar that runs across, that is where the dash is actually going to mount to. Because this is a fiberglass body, this is all, not a factory vehicle. So you have to create all this stuff from scratch. There's no mounting points, there's nothing. So you have to make it all. So we're actually 3D printing the dash as well. So all this whole thing is going to be all in CAD. And then this is how you have the brake booster support, the mount for the brake pedal, and the column mount, which all of this actually ties into the hood hinge. On a 41 Willys, there's usually like a piano hinge that's on the back of the hood. So we're getting rid of that, and we designed our own hood hinge. So this whole structure actually ties into the bottom of that. So it's all very strong. We try not to rely too much on the fiberglass itself. We try to make a lot of metal structure that actually ties back into the chassis. And then, I think that was it on my end for the examples. These are just a couple small examples. We use a scanner, sometimes multiple times a day for different things. We use it in so many different ways. And I think the Leo has worked out really, really well for us because of how portable it is. I've flown with it in a case, which is a little bit nerve-wracking, but I've flown to go scan a vehicle, and it's worked out really, really well for us. It's been such a huge, huge tool for the shop. And when you combine it with 3D printing and with the laser cutter that we have, we can make a lot of different stuff with it.
My name's Kyle Burdine. I'm the director of sales here for Digitize Designs. I handle all the sales, management, new business development, and handle a lot of the key accounts with our team as well too. I've been with Digitize Designs for a little over 5.5 years now, but have been in the measurement industry of some sort for about almost 15 years now. Have the opportunity to work with a couple different OEMs as well as a couple different resellers. So it kind of gives me a broad range of maybe what customers might be looking for from the perspective of working with different people and different companies and that kind of thing. Just discussing their workflows and needs and just overall understanding the industry better. I think it really helps us serve our customers better. So that's a little bit about me. As far as Digitize, we've been in business for about 10 years or going on 10 years. This is year 10. I can't really remember all the time. And we specialize in selling scanners and software. It's all we do. It's what we specialize in. It's just scanners and software related to 3D scanning, whether it be inspection and metrology or more reverse engineering and design, like kind of like Dom's talking about, what we're talking about here today. As far as Digitize, we do about a quarter of our business is also service projects. So I like to think that it really keeps our engineers very up to date on their toes. Right, we'll go out to a different company and work as if we're one of their employees, scanning their parts and either inspecting one of their parts or bringing it back to the office and maybe drawing up CAD for them and that kind of thing. So a lot of times people maybe don't want to buy a scanner, or they have a scanner that can't fit the needs of a project that they've got, so they come to us for help on those as well too. So it's kind of that, and I really feel that helps make us an expert in the industry, right? I mean, even with our peers, they come to us a lot of times with big projects and ask if we can help them because our engineers are so good. And like I said, we specialize only scanners and software. There's people out there that sell scanners, but they also sell, big bridge CMMs or other products, maybe printers or things like that. And so they maybe don't specialize like we do. So as far as Digitize is concerned, we represent 3 different brands of scanners, but we're going to focus solely on the awesome Artec lineup today. The one thing I love about Artec, or one of the many things I should say I love about Artec, is the range of scanners, right? So we're looking on the screen here, all the different scanners that they've got available. Something as small as the Artec Micro can scan something as small as, say, a mouse tooth or a coin. If you want to get the edges on the side of a coin, you can get that up to the opposite of that with the Artec Ray. You can scan a whole battleship or a golf course or a stadium. So, and anything anywhere in between. So there's a lot of versatility when it comes to the Artec lineup of scanners. And then we've got software available, about 8 different manufacturers of software we work with, depending, again, like we talked about, metrology and inspection of parts once I've made them, maybe comparing to a CAD model, that type of thing, or reverse engineer and design, where I want to actually take the part and turn it into something different, develop the CAD for it, that kind of thing. As it says on the screen here, we are an ambassador reseller for Artec. And what that means, well, it means a few things. So it means, A, we're an expert on all of the products that Artec has. We carry all the Artec products. So everything on the screen here we have in our office, located in Greenville, South Carolina. That's where our headquarters is. And it also means we've achieved a high level of customer service and support. We've even passed, there's an annual test you need to pass to become what they call gold certified. We've done that 8-10 years running, something like that. So it means, again, that, as I kind of alluded to already, our engineers are very much experts in the industry. They understand the product very well, and they help a lot with that. And I think, well, I know that comes to help with customer service down the road, right? When someone purchases something from us, it's not the end of the relationship. It's really just the beginning. We're there to help you with questions you might have, or that type of thing. We've been working with Dom and his team for 5 years or something like that now. And at first we'll get you the equipment. Second is we get you some training. Maybe I heard from Dom a few times in that first 6 months after that, like, hey, got a new project. How would I do this? And then I'll be honest, I don't hear from Dom much other than just checking in every 6 months or once a year, just to say, hey man, how's it going? I saw the cool new project, or that kind of thing. So, but we're there to help in case, even now, even if he's got questions and that kind of thing. So, but yeah, it's really focused on the service and support. But we'll get into that in the next slide too. So as far as, like it says here, where we operate or what we do, we work with automotive, aerospace, heavy machinery, machine shops. A lot of industrial type anything industrial we work with. But we also do things like heritage preservation, archaeology, and a lot of things like that. And of course, as we've discussed here, anything in the car industry. We'll talk more about the car industry in a sec. But a couple of the neat little projects we've worked on, I just like talking about, is and things you never think about maybe using a 3D scanner for, I think is what it's turned into, right? I think everyone knows you're using a 3D scanner in the automotive industry, right, or something like that. Sometimes people don't think about other applications. One, for instance, we had a high-end comic book dealer come to us. And obviously in the comic book world, I think like baseball cards, whatever, it's got to be in this perfect mint condition. So with comic books, what people will do is apparently they will try and iron. I don't know how you can iron paper, but iron it to get the edges out and creases out. So we've used an Artec scanner to scan the comic book to be able to see any kind of small creases. We're talking these accuracy of these scanners are, 1,000th or 2,000th of an inch. You can see every little crease and crack. And so they're able to value their comic books based on the data that they found. A couple other fun ones are we have someone that's verifying high-end retail shoes and handbags, just authenticity versus, say, fake knockoff of Louis Vuitton or Yeezy shoes, stuff like that, whatever. And then, funny, I didn't know you were going to be sharing that today, Paul, but oddly enough, Curtis Cabs is actually a customer that we worked with as well. The CPE is another customer. So two of the people you shared today are actually people we've all, I don't think you did that on purpose, but anyway, kind of cool. There's also a webinar online with Artec for Saucony shoes that we worked with as well. And then we actually have worked with some NASCAR teams and stuff as well too. So a lot of different options with regards to that. So a little bit about kind of our process, kind of what we do, how we work is we take a real, like I said, kind of a consultative approach to find the customer needs, right? So, if someone comes to us, they call us up, say, hey, I'm thinking about 3D scanning. What do I do now? I want to know about your use case. I want to know your workflow, what you did before, what you've done in the past, maybe what your experience is with CAD or not, or kind of what just in general, kind of what you plan to do today. And then maybe what you might also grow into. I think Dom just said it. I think they were planning on using the scanner for a couple different things here and there. And now, like Dom said, we use this thing all the time, 2-3 times a day for lots of different things, probably things they didn't plan on using it for. I'd love to hear more about that, Dom, at some point. But anyway, and so again, back to the process. So we do that. Then a lot of times we work on like a web demonstration, something like this, a Zoom Teams meeting where someone says, okay, we've identified that maybe the Artec Leo, the Micro, or the Spider are one of the scanners that really we think is great. So we'll get on a Teams call, show a web demo, maybe scan one of our parts. Maybe they ship us one of their parts and we scan one of their parts and show what it would look like actually in a real life or almost real life scenario. And then from there, we do more discovery as far as what they're looking to do with it. We talk more about that workflow and the software, things of that nature. Because the one thing we haven't talked about too much here is the power of the software. The Artec Studio software is incredible. The Artec, sometimes we joke that Artec is like a software company that also has scanners because their studio software is very good, very powerful, and they're always doing very good updates to it as well too. But anyone in the industry that we work with, we really specialize in that, and then we always specialize in after purchase kind of support and training, and really focus on that as well too, because we want to see someone sharing things online, or we want to, Dom, like I said, we've been working together, I think it's 4 or 5 years, and here we are now doing this webinar this many years later, so they're still getting value out of it, which is awesome to us. One testimony, I think, to our level of service and support is that Tucci didn't come to us directly. Actually, they were referred to us by someone else in the industry, someone else that we took care of on a scanner, and thought we did a good enough job that they'd refer a friend to us or a business partner to us. And I think that's the ultimate compliment as far as that's concerned, is someone gets referred, they trust the relationship enough to put them in your hands, and we take pride in that. That's a big deal for us, is making sure that you're going to get taken care of. And I think since then, Dom and the team have paid it forward. I think 1 or 2 people we worked with since then have been referred to us from Tucci, so it's kind of all come full circle. But anyway, as far as the workflow a little bit with Dom and the team itself, they came to us, wanted to streamline workflow, increase throughput. As Dom said, you're measuring, like, what was that Ford Fender? It sounded like that would have been an absolute nightmare to try and measure by hand. A lot of times people are using cardboard templates or cutouts or tape measures, and now we're talking scanners that can do within a couple thousandths of an inch accuracy. So it's really a big change from the amount of data you're going to get. I remember when we first talked, I still can't believe that you were even able to get any usable data from the Xbox Connect, which is probably a testimony to you being able to figure out the technology more than anything, but whatever. But a lot of people in this industry use the Leo for a myriad of things, but it's the leader in the clubhouse, let's say, when it comes to automotive industry for sure. So this is just, again, Dom showing you how easy the thing is to use. I've got, you look at the pictures here, one thing that makes the Leo so easy, and I know, Paul, you kind of cover this, but just the screen on the back, right? Everyone's got a cell phone, right? Everyone knows how to use a cell phone and pinch and move, and just makes the Leo super easy. I always say you can drive up to a site, jump out of your vehicle, scan whatever you want, jump back in, drive away, and download the data later. So it's just super easy to use, super user friendly, and it's a simple workflow. As far as kind of where we we work in the industry or that kind of thing. You can read all the things on the slide here, but for us, the industry cases relative to the vehicles would be, I say hot rods. I'm not in the industry. That's probably not what anyone actually uses the term hot rods, but hot rods, custom parts for higher horsepower. I think Dom used the terminology like performance industry, right? Maybe custom one-offs. I think like Tucci's doing, and some other folks who work with them, they're taking this base car and now just adding style to it, or adjusting the frame, or all the things that we've seen already today. And again, they're taking these cardboard templates, and sometimes, some of the people we worked with they're taking a cardboard template and then they say, okay, we think we're good. And they make this part and it doesn't fit. So they go back with another template and they make another part. And so a lot of time is spent on that, a lot of money and materials, and, and that kind of thing. So the 3D scanner doesn't ever measure wrong. It's always going to be accurate, like I said, within a couple thousandths of an inch. So it doesn't make mistakes. You can see the scan data on the screen, like we saw in that last picture there, as you're scanning. So if I miss a corner, I can just go back and make sure I get it. So there's no missing of an edge or something like that. So it cuts down immensely on the time to market. It speeds up the entire process, less scrap, less wasted time, and it just increases throughput and immensely. So some of the other companies work with, like doing off-road vehicles where they're doing a roof rack or front bumper cover or rear door covers and things like that as well too. Another company we work with actually is using it for safety in the instance of catalytic converters, right? Sometimes get stolen, cut out of cars, that kind of thing. We work with a company that's using the Artec Leo to scan the bottom of vehicles, and I don't know the brands exactly, but scan the bottom of vehicles and make then a cover for the catalytic converter to prevent them from being stolen. So that's a huge industry in and of itself, and they have a massive facility because they're working directly now with OEMs providing these using the Artec Leo scanner, same as what Dom uses as well too. So that's a little bit about the process and the industry and everything that we're working with, and relative to maybe automotive and that type of thing.
I mean, it's something that I've always wanted from the beginning. It was just, if we could make it happen for the shop financially, it's a big cost for, a small business, but man, is it worth it. Yeah, the Xbox was like, it would get me kind of close to some semblance of a surface, but then it would be like print, test, change, print, test, multiple times. Whereas with the Leo, it's good right off the bat. It's pretty awesome. It's like cheating. Feels like cheating. I think once you start using, once you get your hands on one, even to test, or if you have the opportunity for that, you'll see how much it really helps with. I mean, in our shop, you're hand making things that don't exist anywhere else. So where are you getting, you can't, there's no CAD of the surface that we just made. So you have to scan it, or like the way we would be templating with cardboard. We used to template with cardboard all the time, and just the amount of time savings it cuts off. We're only 3 of us in the shop right now, so it's basically become our fourth person in the shop.